Hey everyone, welcome back to the channel Code with AKJ. Today is day 18 of solving Geeks for Geeks problem of the day. Today's question is minimum cost path. So the question says here, given a square grid of size n, each cell of which contains an integer cost that represents a cost to traverse through that cell. We need to find the path from the top left to the bottom right cell by which the total cost incurred is minimum. From the cell I, j, we can go to upwards, downwards, right and left. So imagine that you are in a maze and each cell has a cost associated with it. And our goal is to find the path from top left to the bottom right that incurs the least cost. So let's dive into this problem and understand the brute force approach of this. So let's understand the question through this diagram. So given a square grid of size n where each cell contains an integer that represents the cost to traverse through that cell, we need to find the path from top left cell, that is 0 comma 0, to the bottom right cell, that is n minus 1 comma n minus 1, and we can move up, down, left and right as I have explained through this diagram. So we'll start with the brute force approach here. The idea here is to try every possible path from the top left to the bottom right and calculate the total cost for each path. So let's break it down here. Like, we can use a recursive function that starts from 0 comma 0 and explores all possible paths. So for each cell we either can move left, right and down or up. So the base case here will be when we reach the bottom right cell, that is when I becomes n minus 1 and j becomes n minus 1, will return this value which will be stored at the bottom right cell. So for all other cells, we recursively calculate the minimum cost from the neighboring cell and add the current cell's cost with it. So let's code this particular approach and see whether it gets submitted or not. So this is the code of the brute force approach we have discussed through the diagram. And initially I have taken the grid size and stored it in variable n. And I have also taken the 2D vector of size n, which is named as visited. It generally helps us to track that particular cell is already visited or not. So for example, when we move from 9 to 4 and again from 4 we'll explore all the possible paths, and when we move from when we try to check the left value, we can easily find that 9 is already visited, so we'll ignore this part, which will help in reducing the call stack. So in this way we'll maintain a 2D vector of size n, which will make sure that this that particular cell is already visited or not. Initially it will be marked as -1, which means it is not visited, and when it will be visited we'll mark it as 1 or any other value. So in this way we'll take an extra space of O of n square, which will help us to track that particular cell is visited or not. I have called the function DFS and I've sent the two indices value as we are starting from 0 comma 0 initially. And again I've taken the size of the grid size here, and this would be the base case. If this indices reach the bottom right cell, will return the value of that grid. And finally we've taken the minimum cost, which will be initially a large value as we need the minimum value at the end. I have taken the vector of pair, which generally stores the direction of left, right, up and down. And for that particular cell, we'll explore all the four possible directions. So our new index would be the current index plus the directions value, and the new column index would be the current index plus direction value. So after grabbing those new index values, we'll check that if particular value is valid or not. Why we are checking beforehand? Because if, for example, we are at the cell 6 and we are trying to explore the left value, since this goes out of the matrix, so it is not valid. So we'll check for each particular value if it has up value or right or left or down. So this is a mandatory step to check whether the cell has a valid left value or right value or up value or down value. So we'll have a isValid function where it checks whether this index is going out of bound or not. So finally, if valid function gives a true result, then we'll calculate the current cost and we'll update the minimum cost by taking the minimum of it. And finally, we'll store all those values, a 2D vector which we have taken, initially. So this visited vector will store the cost for each cell. So after calculating the cost and storing all the current cost for each particular cell I comma j, finally when we reach the bottom right cell, it will contain the minimum cost traversing from 0 comma 0 to the bottom right cell n minus 1 n minus 1, and finally we'll return the end value of this grid. So let's compile and run this solution and check. As you can see, this gives a runtime error. This happens only because of two reasons. Because of the stack overflow due to deep recursion. So for example, if the grid is large, for example 1000 cross 1000 or more, the depth of recursion could cause a stack overflow. So as DFS calls stores the stack recursion value in the stack, the many more call stacks may overflow this size of the stack and can cause us runtime error. So since here DFS is implemented recursively, each recursive call adds a new frame into the stack, and deep recursion might exceed the stack limit, causing us a runtime error. Another reason would be unintended infinite recursion. Here possibility is that recursion could cause infinite loop if certain conditions in the call stack is not handled properly. So this would be the two possible reasons for the runtime error. So let's try to optimize this approach and use an efficient method to solve this particular problem.
So let's move on to an optimal solution. Since this question asks us to find the minimum cost from left to right, the only algorithm we can think of is the extra algorithm, which generally calculates the shortest path from a particular vertex to all the remaining vertices. So you can go through this particular article where they have explained each and everything about Dijkstra algorithm. It generally works for both directed and undirected graphs. So how we can use this particular algorithm in our question? So if we carefully look this particular grid, can we consider it as a undirected graph here? So I have drawn this visual representation of this particular 2D vector in the form of undirected graph, considering each and every cell as a vertex. How this particular algorithm works is, initially we'll take the value for each and every cell as int max, the distance from one particular cell to every other vertices, and we'll use the help of q, and we'll store the values as a particular cell value, and corresponding to that value we'll store the indices I comma j. So we'll use this particular format of storing the values into the queue, and one by one we'll initially pop that particular value and explore all the possible directions, that is up, right, down and left, and we'll calculate the distances from that particular cell, and we'll update that particular distance in our 2D vector which we have taken as an extra space. So the first iteration be as follows. Since we take this particular value and we'll push it into the queue, we'll store it in the form of value and the indices, as the indices will be 0 and 0, and we'll calculate the distance all the particular directions. So when 9 moves from right from its position, the value would be 9 and 4. So this particular cell will be updated with the distance 13, and from when 9 moves from 9 to 6 to this particular cell, it will update its value 9 plus 6 equals to 15. So in this way we'll try to update each and every cell, its distances from this particular cell, and finally when we reach at the final cell, that would be bottom right, this particular cell would have the minimum cost or distance traversed from this particular cell 0 comma 0. So let's code this approach and we'll check whether it gets submitted or not. So this is the code for our optimized approach we discussed, and here I've taken the queue as a min heap as we implemented with the help of queue. I've stored the value in the form of pay, where first int will represent the cell value and then second pair of int will represent the indices value. Taken an extra space of distance, which would be initialized with int max initially. We'll push the first cell, the value and its indices. We have taken the directions in the form of two vectors. Initially the distance vector of the particular cell would be 0, as the distance from that particular cell to itself would be 0, and we'll run the while loop. We'll take the distance value, the row value and the column value from this format, will pop that particular value, will traverse for all possible paths, the up, down, left and right, and will again check whether it's valid or not to traverse to that particular position. And if it is valid, we'll update the distance of that particular cell to the another cell, and if it's updated, we'll store that value in the distance vector, or else we'll neglect it. And if we find any distance minimum to that current value, we'll push that into the min heap. So in this way, we'll store all the values into the min heap, and the values will be updated in the extra space distance vector, and finally we'll return the last value, which will store the minimum cost path which we have incurred traversing from the top left value to the bottom right cell. And here the is valid function would be same as that. If any of these conditions satisfy, it means it is out of bound, or else we'll return 1 here. So let's compile and run this approach. It's working fine, so let's submit. As you can see, this problem got submitted successfully. So in this way, we have reduced the time complexity and space complexity. As we have observed, we were getting runtime error while using recursive approach. So you can go through this algorithm in more detail using this particular article provided by GeeksforGeeks. It will provide each and every important point, its need and advantages and disadvantages for this particular algorithm. So this is it, guys. I hope you like this video and explanation. If so, please give it a like, share with your friends and subscribe to my channel for more such videos. I'll see you in the next one. Thank you.